Yes, good afternoon. Welcome to today's discussion. That is on paper 2, Kcse of 2021. Kcse of 2021. Welcome. In case of further queries, you can find me through my WhatsApp number 0757 01 90 11. Comment, like, subscribe, and don't forget to share. Welcome to today's episode once more. This is Kcse of 2021. This is the first question. It is about the rectilinear propagation of light, especially on reflection. Then you're told that this diagram is showing us ray that is at 30 degrees to the reflecting rays. Then you are asked complete the diagram and show the path of the reflected ray. Complete diagram and show the path of the reflected ray. In this case, you first have to understand that we have the laws of reflection, that the incident angle must be equal to the reflected angle. Therefore, I'll first draw my normal like that. Then I will proceed and draw my reflected ray. The accuracy may not necessarily matter. The accuracy of the degrees may not necessarily matter. What matters most is the issue to do with understanding what is the size of the angle and also giving out a completion by showing the direction of the ray. So you either show that the reflected ray will also be at 30 degrees to the reflecting surface, like that, or you show that the incident angle, which was at 60, the incident angle will also be equal to the reflected angle, which will also be at 60 degrees. Don't forget, even if you get it correctly drawn without the ray direction, then you'll have to miss the marks. You'll have to miss the marks. The reason being, any ray diagram without ray direction, then it's always wrong. It is always wrong. Proceed to question number 2. It is from Electrostatics 1. You are told that the figure 2A, 2B, and 2C, they do show the process of charging an electroscope by induction. Then you are told that it is observed that the leaf rises in A, collapses in B. Explain why the leaf collapses in B. In this case, the question is specific, that the thing that we need to explain is all about part B. If we charge a body by induction method, we do expect to have the opposite charge. But right away now here, we have several processes that will happen. We have several processes that will happen. The first thing, when this polythene rod, which is negatively charged, the positive charges were attracted. The negative ones were repelled away. Looking at the second case, we can see we are having earthing. The question is, how will the flow of electrons move? In what direction will it move? Therefore, if we have it like this, we should ask ourselves, which is the best direction for this one? Because at long last, we do expect to remain with the positive charges. Therefore, if we concentrate with part B, we'll finally say that these electrons were earthed, and therefore, you can say that the electrons, the electroscope is earthed. The electroscope is earthed. Thus, the electrons flow from the leaf, to the earth. This reduces the repulsion. On the leaf. And this is now what makes the leaf to fall. As the leaf falls. So the direction of the flow of electrons will be moving towards the earth. We can move to the next question. Which will be state 1 use of capacitors. In this case, many people will forget about the uses and start defining the capacitor. Therefore, you should not include the definition of a capacitor in this case. We have several of them, but you are supposed to stick that it is one. So we have several. You can either say smoothing circuits. We have tuning circuits. We have delay circuits. This is the one that is used in the flash. We can also proceed to the next question, where we'll be having a question on magnetism. The figure shows a graph of magnetic strength against time for two nails, that is P and Q, when magnetized in a solenoid. P and Q are of the same size, but made of different materials. So we are having the magnetic strength, and then we have time. Then the question 1 is, identify the material that is magnetized faster. Therefore, this question can be responded by using the same time and look at the kind of magnetic strength that will be required. So they have been magnetized, but this is now the newly acquired magnetic strength. Remember, they are being magnetized in a solenoid, meaning that this is magnetization by electrical method. Therefore, if you look at the magnetic strength of both P and Q, you will realize that P acquires a lot of magnetic strength within the same time, while Q acquires very less magnetic strength. So you can say P is the right choice for this case. The next question, use the domain theory to explain the answer. Use the domain theory to explain the answer in the above question. Therefore, in this case, you must understand what is being required. The question is very specific. Therefore, we need to look at what is to be considered from the domain theory. What is to be considered from the domain theory. Then, we'll talk of the arrangement of the dipoles in the domains. Therefore, you can say that the dipoles of P are aligned faster than in Q for the same magnetizing strength. The same magnetizing strength as P and a higher, as P and a higher magnetic strength and higher magnetic strength. If you compare the times, then in a shorter time than Q. What does this one tell us? We can say at long last, P will be likely to be a soft magnetic material, and Q will be a hard magnetic material. We can establish that one in terms of conclusion. State the meaning of principal focus of a convex mirror. The principal focus of a convex mirror. In this case, principal focus for both mirrors and lenses are defined in two ways. They are defined in two ways. Both the convex and the concave. But for the convex mirror, it is the point on the principal axis where all the rays close and parallel appear to diverge, because we are being questioned about the convex mirror. When it comes to concave, Then there is a point on the principal axis. We are always close and parallel. Do converge after reflection. Then now we can proceed to the next question. We're having this question here. It is on magnetic effect of electric currents. The thing to do with a force that is caused by a current conductor interacting with a magnetic field. In this case, X and a circle means current into, Therefore, the first thing, you can see that the field lines are the ones which are being questioned. But for us to acquire the correct and the proper sketching of the magnetic field, we also need to consider where will be the resultant force, because we must look at where do we have a strong side of magnetic field and where else do we have a weak side of magnetic field. So in this case, we'll first ignore the magnets, then draw a single field line for the time that the current will be flowing on its own. Therefore, using the right hand grip rule like this, that this thumb is pointing the direction of the current, which is now into. So holding it in this manner, then I'll have my field line around this conductor in that manner. It is moving in anti-clockwise direction like that. Then now, I will use the Fleming's left hand, where I'll have to draw or else to show which side will we be having the resultant force. Which side will have the resultant force. Therefore, the field is moving from this part towards the south. Therefore, this is my first finger showing the direction of the field. Then this finger should show the direction of the current. This way. This means that at long last, if I have to put my hand like this is the field, this is the current, this will be the resultant force. So my resultant force will be moving downwards. And if it is moving downwards, it means that we will say that on the upper part, we are having strong field. Whereas on the lower side, we are having a weak field. So I'll show my strong field in that direction, in that manner. The field lines are very close. But since this part, we are having a weak field, so that we can establish in which direction the resultant force will be moving. So the resultant force will finally move downwards. The question doesn't ask you about the resultant force F, but I have indicated because it is the one that is going to help us understand which side will have strong field. So this one is strong field, and this one is weak field. And then now, don't forget to show the direction. Don't forget to show the direction in that manner. We'll take time also to consider the issue to do with magnetic fields, that is magnetic effect of electric current, and discuss it in detail in another day. The next question, we are told that we are having two coherent sources, and we are having sound from A and another one from B, which are in phase. O is a point that is equidistant from A and B. Then you are told an observer moves from M to N through Q. Explain what is observed at point Q. If you look at point Q, it is at the center. The first thing is to understand what does this question require. This question is asking all about consideration of interference. Then what will be happening as one moves along MQN? We do expect to have a loud and soft sound. But where do we expect the loudest sound? It is at the center where we are having Q. And this is as a result of constructive interference. Therefore, we have been awarded 3 marks. Therefore, we need to first mention the explanation, what is going to be observed. So the first thing is that a loud sound is at Q. That is the first mark. Then we now try to explain so that you can acquire the remaining 2 marks. Therefore, sound from A and B are in phase, Hence, interfere constructively. And why do they have this constructive interference? It is because they arrive at Q at the same time. They arrive at Q at the same time. They arrive at Q at the same time. Can proceed to the next question, where we are having state 1 factor that affects speed of sound in water. The question is very straight and categorical, that it is in water, and you are supposed to give only 1 factor. I'll give several, but once it comes to exam, always stick to the number of points that the question is demanding you to. Therefore, many people will know that the factors affecting the speed of sound is all the way from air, but this one is now water. Therefore, there are some factors that will affect sound in air, but they will not affect sound in water. The first thing, what we can point is temperature of water. The temperature of water. How does it affect? An increase in temperature increases the speed of sound. Then the second one, we say that a salty water, the speed of sound in a salty water will be higher compared to the speed of sound in fresh water. Therefore, the factor of density comes in. Therefore, we can include density of the water. We're having the next question here, where we are told that the figure shows a ray of light incident on a prism with a critical angle. So we have been told the critical angle is 42. Then you are told complete the diagram to show the path of the ray through the prism. Many a times students will rush and complete the diagram without understanding what concept is being tested. What concept is being tested. Therefore, in this case, we must first understand what does this critical angle require us to do. Therefore, if you consider this incident ray, it is perpendicular to this surface. Therefore, it will penetrate through and deviated. So it will penetrate through and deviated. If you look at this angle, it is 30, 90, meaning that this one will be will also be at 60 degrees. And this now is an incident ray to this surface. Therefore, if I draw a normal line like this, then I'll have my incident angle being at 30 degrees. There is a statement for the occurrence of reflection, total internal reflection to occur, and when a refraction will occur. We usually say that if the incident angle is greater than the critical angle of the material, then total internal reflection will occur. Therefore, our critical angle, our incident angle now, which is 30, is less than our critical angle. Therefore, in this case, we do not expect total internal reflection to occur, but refraction will occur. But when the incident angle is greater than critical angle, then here we say total internal reflection. Total internal reflection is going to occur. Therefore, in this case, we just need to understand in which direction will our refracted ray move. We say that if it is moving, if the incident ray is from a denser medium to a less dense medium, then the refracted ray will move away from the normal. Then the refracted ray will move away from the normal. Then I'll draw my refracted ray in that manner. And if the incident ray is moving from an optically less dense medium to an optically dense medium, then this one would move towards the normal. So that one is now sorted. It is 2 marks, the way it entered and the way it will emerge. Therefore, now we can proceed. Next one. It is observed that when heat current of the cathode ray is is increased, the intensity of the cathode ray also increases. Explain this observation. We know that the production of cathode rays, it depends on thermionic emission. It depends on thermionic emission. Heating effect is only brought about by current. Therefore, if you increase the heat, then it means that you are also dislodging more electrons. This in turn will increase the intensity of the cathode rays. Therefore, you can say increasing the current increases the heat. This in turn increases the number of dislodged electrons, the number of electrons dislodged through the thermionic emission process, increasing the intensity of cathode rays. Increasing that's the density. Question 11. A current of 2 amperes flows through a bulb for 2.5 minutes. Determine the quantity of the charge that flows through the bulb. Therefore, current is the rate of flow of charges. Therefore, we know that current is given by Q over T. In turn, this shows that Q is given by IT. Remember, our time is supposed to be given in seconds. Therefore, we'll have a current of 2 amperes multiplying by 2.5 minutes, convert them into seconds. And this will make you arrive at 300 coulombs. Will make you arrive at 300 coulombs. If you arrive at 300 coulombs, many may know the units, others may forget the units. So, it is 3 marks, correct substitution, answer with the correct units. Answer with the correct units. Then now I can proceed to the next question. Proceed to the next question. You are told that this figure shows UV light passing through an aperture and incident on the cathode of a photo cell. You can look at the diagram the way it is. State what is observed on the millimeter when the size of the aperture is increased. State what is observed on the millimeter. So we know that millimeter is used to measure current, but in this case we cannot see the current. So what can be observed only is the issue to do whether there is deflection or there is no deflection. Therefore, the moment we are having rays here, UV rays or radiation, we expect that the cathode to have dislodging of electrons, then they will complete the circuit. Therefore, we expect in this case to have a deflection of the milliammeter scale. But the question is very key. When the size of the aperture is increased, meaning that there is no way we can just look at it and respond to the question blindly, because it is specific when the aperture is increased. Therefore, we know that it will deflect. But if the aperture is increased, what else will happen? Therefore, we do expect that the milliammeter deflects. And now we describe from when it is increased, deflects more. Why? The reason is asked here. Why is this deflection increasing? The reason will be the moment you increase the size of the aperture, then we expect more electrons to be dislodged. Therefore, increasing the aperture increases the light, which in turn increase the number of photons, and this in turn will bring about more electrons. Hence, more electrons will be ejected, dislodged. Ejected or dislodged. It will be ejected or dislodged. You can still proceed to the next question. State the property of radio waves that makes them suitable for use in communication. Makes them suitable for use in communication. We know that all the rays or the things from the electromagnetic spectrum, we have the issue to do with variation of wavelength and frequency. But the key thing here to do with radio waves is all to do with the wavelength. Because in the hills, they must be diffracted. In case of any barrier, they can also be diffracted. In short, they are able to move or bend following the kind of obstacle that they meet. Therefore, you can say they have the property they have long wavelengths, and this in turn makes it easier for these waves to be refracted. So you can say hence easily diffracted. Hence easily diffracted. Hence easily diffracted. we can proceed. We can proceed to the next one, and it is now in section B. It is now in section B. We are told that state and explain how increase in temperature affects the conductivity of a semiconductor. Many will skip the term semiconductor and remember only about conductors. But this one is a special case because we need it to be only for a semiconductor. So do not forget about the issue of the temperature. It's only affect a semiconductor. Many will forget and go for how temperature affects conductivity or resistance in normal conductors. Therefore, in this case, an increase in temperature, an increase in temperature increases the conductivity of a semiconductor. The conductivity of a semiconductor. And now, because it has been awarded 2 marks, that is just the first thing you have just stated. You need to support your argument. Therefore, higher temperature increases, higher temperature increases the kinetic energy, increases the kinetic energy of the electrons, and these will make them to be able of the electrons to jump from their valency bands. That is how it comes in. We're having a graph here where we have the relationship between potential difference against current, potential difference against current. Then you are now told to explain why the paths of OA is just straight, whereas the one for AB is curved. Many a times when you are given graphs, you are supposed to respond in terms of what does that graph finally represent. If you look at this side, like that, we can see like the gradient is the same. And the gradient of this one is giving us a resistance. It is giving us resistance. So, if you have to explain about OA, then we consider the representation of the graph, which is resistance. Therefore, at OA, it is straight because the resistance is constant. The resistance is constant. At AB, like that, you'll find that as the potential difference increases, the rate in which the current is increasing is a bit slower. So if you have the formula of R is equals to V over I, then if this one is in small or else in a small value, then we expect this one to increase. Therefore, AB, you can say the resistance increases. The resistance increases. Now, it has been awarded 2 marks. You need to get back to the question and look at the description of the first thing. So, potential difference across a bulb against the current. So we are talking of a bulb. The moment you light a bulb, at long last it will start producing it. And an increase in heating effect will increase the temperature. And an increase in temperature will increase the resistance. So the resistance increases due to increased heating in the bulb. Due to increased heating in the bulb. We can now proceed to the next one. A circuit consists of 20 identical lamps connected in series to 240 main supply. Determine the potential difference across each of the lamps. Determine the potential difference across each of the lamps. You're told that these 2 lamps are identical and they are in series. Therefore, we need to understand what will happen to voltage or potential difference in series. We know that PD in series is shared, but in parallel is the same. Therefore, in this case, we just need to have 240 volts being shared by these 20 identical lamps. Therefore, each will have a potential difference of 12 volts. 12 volts. So, this and this will be very much okay. Be very much okay. We are having a circuit consisting of 2 identical lamps. 3 ammeters A1, A2, and A3 connected to a cell. This is the cell. We have ammeter 1, ammeter 2, ammeter 3. If we look at this one, we are having this lamp and this one. We have been told that they are identical. The moment that they are identical, it means that any resistance in them will be the same. But now, the key thing here is that we need to understand in which arrangement are they in. These and in parallel connection. They are in parallel connection. Therefore, current in parallel connection is shared. But current in series, it is the same. So this one is in parallel. That was just a brief explanation of the diagram. Given that ammeter 1 reads 0.5, this is the total current that is coming from this cell. It is 0.5 amperes. State the reading on the ammeter A3. State the reading on the ammeter A3. And in this case, we'll just see that A3 and A2, the two of them will share that current. Therefore, it will be 0.5 divided by 2. You arrive at 0.25 amperes. You arrive at 0.25 amperes. Explanation here. The explanation here will be that the lamps are in parallel. Current is shared. Current is shared. We can proceed to the next one. Where we are having state the use of eyepiece lens. State the use of the eyepiece lens. From a compound microscope. We know that a compound microscope has eyepiece lens. We have the objective lens. So the objective lens is the one that magnifies the specimen. And then the eyepiece now will further magnify the image formed from the objective lens. Therefore, you can say to focus or magnify, to magnify further the image from the objective lens. The image of the objective lens. We must be very categorical that the image from the objective lens is the one that will be magnified by this eyepiece. The one that will be magnified by this eyepiece. We have a question here which is asking us, on the grid provided below, draw a ray diagram to show how a convex lens forms a magnified and a real image. A magnified and a real image. A magnified and a real image. Underline the term, it must be magnified and it must be real. Therefore, just need to draw a principal axis here, like this. Show the kind of lens that is being used. And we are told a convex lens. A convex lens is a converging lens. Therefore, it is shown in that manner. You choose whatever length that you want to have for your principal focus, F, in this manner. In that manner. Therefore, you need to understand under what conditions does a convex lens form a magnified and a real image. And if you get to the drawing board, you'll find that it is only when the object is between F and 2F. Therefore, just need to go straight to where we have F and 2F. So you can establish your own objects like that. We have the first ray that will guide us to form the image in this manner. Therefore, the first ray is a ray that is close and parallel to the principal axis. A ray that is close and parallel to the principal axis. This ray will be converged at F. Will be converged at F, like this. Be converged like this. Then now you can use the second ray, which will be a ray passing through the optical center. It passes through and deviated. It passes through and deviated. And this becomes that ray. That becomes that ray. Then you show the direction of the ray. And in this case, where the two rays converge, we have our image formed at that. And you label it I. Therefore, this will be half a mark. Sorry. Okay. Half this part, another half. Those are 2 marks. We are not interested with the drawing of the object, but this image drawn here will be awarded 1 complete mark. Then you are supposed to note that any ray diagram without ray direction is awarded 0. Is awarded 0. No matter how careful you are, if you don't complete by showing the ray direction, then you will mess with it. We're having this diagram here for human eye. We can see that the image formed here is formed behind the retina. Then you ask, state the type of the defect. This defect is called sightedness. And then state the type of lens that is used to correct these defects. It is a converging lens, converging stroke convex lens. Then now on the same figure or diagram, now draw to show how this lens is used to rectify this. We know that the converging lens is just to further converge the rays. Therefore, we can just show it here. Then we try to converge the rays. So before they are converged by the lens from the eye, they are already converged by the lens. So this becomes our lens, our converging lens. Our converging lens. Then we now draw these rays, this man. Now they will be so we expect our new image to be formed here. And then now show the direction of those rays. Show the direction of those rays. We can proceed now to the next question. We can now proceed to the next question. It is a graph. It is a graph of V against U. This one was for a concave mirror. Was for a concave mirror. If you look at it, it is already drawn. Therefore, there is no need to study it further, but you can go direct to the question. Identify and mark point X on the graph where V is equals to U. This one is very simple, where V is equals to U. If V is 10, we expect the U to be also 10. Now, we are following this curve. We show that at our point, we are having the same value of V, which is equivalent to the same value of U. Therefore, if you look at these points at 20, this point, we can label it X because this will be 20 is equals to 20 at that point. There is no any other part where we'll have the same values relating. Use point X to determine the radius of the curvature. Use point X to determine the radius of curvature. It has been awarded 2 marks, meaning that you must have something that you can explain. So, it is in a condition that when U is equals to V, the object then is, at C. The object is at C. Remember, the distance from the pole to the center of curvature is said to be now to the center of curvature is now called the radius of the curvature. Therefore, you can say our R now is equals to 20 centimeters. Is equals to 20 centimeters. Determine the focal length of the lens. Remember, we are tied that we should use the point X. Therefore, we can first say that F is equals to R divided by 2, where you can say 20 divided by 2, we get 10 centimeters. Or we can say 1 over F is equals to 1 over U plus 1 over V, where we'll be having 1 over 20 plus 1 over 20. This will give us 1 over F is equals to this. This will give us 20. This will be 1 plus 1 is equals to 1 over F. Then F will be the same as 20 divided by 2, which is 10 centimeters. You can use that method. Or you say F is given by U plus uv over u plus v. This will be 20 times 20 divided by 20 plus 20. This is 400 divided by 40. You still arrive at 10 centimeters. That is also another method. We can proceed. To the next one. State the Faraday's law. State the Faraday's law of electromagnetic induction. It states that the magnitude of the induced EMF is directly proportional to the rate of change of the magnetic flux linkage. The rate of magnetic flux linkage. We are having this diagram here. You're told that this magnet is moved in this direction. We're having a coil here. We're having a galvanometer. We have side D, we have side C. Indicate on the diagram the direction of the induced current. The first thing is to understand that this one is testing on Lenz's law. It is testing on Lenz's law. Therefore, you are asked on the diagram to indicate the direction of the induced EMF or current. Then this current must flow in a direction in which that on the side of entry of the magnet will produce a pole or a polarity that will create a repulsion. Therefore, this is the direction, and we're having north pole, meaning that D must have a polarity that will repel this north pole. Therefore, our D will have north pole. And now, from the law of the right-hand grip rule, the one that specifies on when you engulf your fingers on a solenoid in the direction of the current, then the thumb will point to the north pole. Therefore, if I engulf my solenoid like this, then D becomes the north pole. Therefore, my engulfing is in this direction. Therefore, my current will be in this direction. Will be in that direction. Like that. That is in accordance to the right hand grip. So we have already established that D is a north pole. So this one is north pole. So now we have been told to explain about this happening of that this is a north pole. Therefore, we can say in accordance to Lenz's law, the induced current flows in a direction that creates a polarity that opposes the magnet. The issue to mention with the Lenz's law, you are very much correct. Then now you explain how does it come in. You're done with that part. Therefore, you can produce to the next part. Which is this one. You're told, apart from the number of turns in the solenoid, state two factors affecting the magnitude of the induced current. Do not fall on the traps of the motions. But here we are talking of the induced current, Therefore, the first one, we have strength of a magnet or the magnetic flux, and now we have the speed of the magnet. We have the speed of the magnet. So we should not repeat the number of turns in the solenoid, but work on the speed of the magnet and on the strength or the magnetic flux. Explain how laminating the core of a transformer increases its efficiency. This one I will explain directly, where I can say that lamination increases the resistance of the core. Hence, resistance of the flow of eddy current. This in turn reduces the heating effect. That's efficiency. There are some more questions that we have not covered, but we can still proceed and finish up. So question 17, explain how a fuse protects electrical devices from damage. This one is different from circuit breaker. So this one uses the mechanism of melting. In case the current that is rated exceeds. Therefore, you can say when the current exceeds the recommended one, the fuse wire melts, disconnecting or breaking the circuit. These will in turn protecting the devices from damages. State and explain why the voltage in the mains electricity is stepped up before long distance transmission. We step up voltage and lower the current. But the main aim of this stepping up of the voltage is to minimize power loss. Remember, the resistance of the wires may be the same, but the thing that we need to consider now here, after we shift high voltage, what will happen to the current? Then from the formula of P is equals to I squared R, for us to lower this, since resistance is constant, we must lower the current. And the current is lowered by increasing the voltage. So from this one, we'll be able to minimize the power loss. We'll be able to minimize the power loss. So just need to have the first point of minimizing the power loss. You give this equation and you explain what will happen. I have said that the resistance remains the same, but what we can deviate is that from stepping up, the current goes down. So if current goes down, then we expect the power loss to be low. We're having the next question, which says that the figure below shows how power can be transmitted from a generating station through transformers P, Q, and R to the consumers. So we are having P, Q, and R. Like that. Therefore, if you look at this one, it came from 11 kilovolts. From P, it went to 133 kilovolts. From Q to this heavy machine, now it is at 33. Bra, bra, bra. Now the question is, identify the type of transformer labeled P. The transformer P will be a step-up transformer. Step-up transformer, because you can see the voltage from the station being increased over number of times. Then now explain how the number of turns in the primary and secondary coils of the transformer affects its output voltage. Remember, for a step up, the number of turns in the primary are less than the number of turns in the secondary. But we expect that the voltage in the secondary to be more, that it has been stepped up. Therefore, what is the purpose of this one? This is to induce greater EMF from magnetic flux linkage. From magnetic flux linkage. Say the reason why one of the wires from Q to the school should be earthed. We already have the term earthing there. So I don't think it will be healthy if we repeat the same term. So the purpose of earthing here is to keep to keep the system, or the wires to keep the system neutral. You can also say to add excess electrons. And where does these electrons come from? The only wire that should be earthed is the neutral wire. Neutral wire is the one that is earthed. Is the one that is earthed. So the purpose can also say add excess electrons that might be flowing. A power station generates 11 kilovolts at a current of 1 ampere. The voltage is stepped up to 160 kilovolts before being transmitted through electric cables. Assuming the transformer is 100% efficient, determine the secondary current. Determine the secondary current. We'll say that power output over power inputs will be giving us the efficiency when we multiply it by 100%. Then you can say 100 is given by the power output, which will be the voltage at the secondary turns, or the second coil. You multiply, that is Vs, and the current at S over the V in P, current in P times 100. So now you can continue and say that our 100 is equals to the 160,000, this one, you use in voltage, times the current in the secondary divided by the voltage in the primary is at 11,000, multiplied by a current of 1. Then you multiply by 100. So this 100 and this 100 can cancel out. Therefore, you can say 100 divided by 100, which is 1, is equals to 160,000 times Is divided by 11,000. So our Is is given by, this becomes already 1. So this multiplied by this. So 11,000 times 1 divided by 160,000. And in this case, you're going to arrive at 0.069 amperes. Don't forget to subscribe. Don't forget to subscribe, like, put your comment, and share. Have a blessed evening.